Hi, in this video we're going to learn how to solve question 1.2a in the Griffiths and Schroeder quantum mechanics book. So this problem gives us a probability density right here from x is equal to 0 to h, and it also gives us the expected value, which is h over 3. So 1.2a asks us to find the standard deviation, and in order to find the standard deviation, this is equal to the square root of the expected value of x squared minus the expected value of x. We already have the expected value of x. Now we just have to find the expected value of x squared. And the way to do that is to take the integral from negative infinity to infinity of x squared px dx. Since px is only valid from 0 to h, that means the integral will be from 0 to h. X squared 1 over 2 square root of hx dx. Now we have to simplify. We could pull out the 1 over 2 square root of h, since those are not functions of x. And this becomes x3 over 2 dx. Taking the integral of this becomes 1 over 2 square root of h. We have to add 1 to the top, it's the exponent, so it's 5 over 2 over 5 over 2 from 0 to h. And these 2's will cancel, so it'll be 1 over square root of h, 5, and since it's 0 here, we only have to worry about this h, so it's h, 5 over 2 is equal to h squared over 5. Since this will cancel with one of these, it'll be 4 instead. Okay, so this is equal to the expectation value of x squared. Now we just have to plug into this equation. And sorry, I missed squared here before. So it's h squared over 5 minus h squared over 9. We can make the denominators the same by multiplying this by 9 and this term by 5. And what we get is a square root of 9h squared over 45 minus 5h squared over 45. Okay, and then these will cancel up here, so then the standard deviation will be the square root of 4h squared over 45, and we could pull this out, and this will be equal to around 0.3h. Question 1.2b now asks us to find the probability that a photograph picked at random will be one standard deviation away from the average. And the best way to start with that is to draw out the graph of the density function. Okay, so this is what the graph of the density function looks like. And to describe the graph quickly, it's a decaying square root function, since square root is on the denominator. And the reason why the function has a lower limit of 1 over 2h is because the bounds of this function is only from 0 to h. That's the only values that x could take. So whenever the function ends here at h, when we plug this value in, this becomes square root of h squared, and the square root and squared cancel, so it's just 1 over 2h. And then the function here goes all the way up to infinity on the left side as it approaches 0. Now if we were to put h over 3 onto this graph, it will be 1/3 of the way, So let's just approximate that it's right here. And one standard deviation away from this is actually very close to 0, because 0.3 is very close to 1/3. So this is what it would look like. So this will be h over 3 plus 1 standard deviation, and then this will be h over 3 minus 1 standard deviation. So the problem asks us to find the probability that it will be outside of the range of standard deviation right here, or the bounds of standard deviation. So we exclude this part here, and we will only take the integral from 0 to this here, and then from this right standard deviation to h. So this is where the integral will be. Okay, so now we just compute the integral like normal, like how we would usually do for probability density, and we'll compute one for the left side and one for the right side. The left side will be the bounds from 0 to h over 3 minus the standard deviation, and we'll plug in the probability density. And then we also have to add the integral on the right side, which will now have a starting point of h over 3 plus the standard deviation all the way up to h. And we could just compute one of these integrals, since the integrals are the same except for the bounds. Then we'll just put the bounds later. So we could take the 1 over 2 square root of h term out, since it doesn't depend on x. And then this integral of 1 over square root of x dx. This will be x 1 over 2, 1 over 2, since we have to bring this up to the top and it becomes a negative 1/2. Okay, so then now we have to, okay, before that, these 2's will cancel, and now we have to evaluate the square root of x over h from 0 to h over 3 minus 0.3h plus the same thing, but now from h over 3 plus 0.3h to h. And we won't have to worry about this 0 since it will cancel, and we just plug this value in. It will be 1/3 h minus 0.3h over h, and then this term will be square root of h over h minus square root of 1/3 h plus 0.3h over h. So these h's will cancel, these will cancel, these will cancel, and we end up having no h's. And then now we could continue computing. We can assume that 1 over 3 is around 0.3 repeating, so this will be 0.03 repeating, and this will be square root of 1, so it's just 1, minus, we'll also assume 1 over 3 is around 0.3 repeating, and this will be 0.63 repeating. So this is equal to the probability that we want, the yellow portions, and this is around 0.39. So this means that if we were to pick a photo at random, there is around a 40% chance that we'll pick a photo within the yellow portions of this graph. Okay, I hope that video helps. Thank you.